on the, guys, listen up for 1 second. On the board I wrote last year's homework, the 1 to 33 odd, and it was a different, whatever one you did, it's fine. Again, it's just the goal is just, they're pretty similar. It's just do some problems in this section. Does that make sense? Whichever one you did, I mean, it's fine. And again, whatever happens, just do some problems in that section, bring questions, and we'll move on. So the one I wanted was the one online. So 2.4 starts right down here. So you're starting on the bottom right, now flip it, and then we'll go through the rest of these. So have your little things out, and I'll check them in. 3 on top.
I know people have done that. So it's like,
should I take the stuff offline temporarily? What do you want to do?
whenever you're ready to fill it.
We'll talk about it. Can you see it? Turn the lights off? Yeah, of course, yeah. Everyone said it was fine. Yeah, just let me know. I don't mind anyway. It's not like, well, like, no, I'm not going to put the lights on. I want you guys to be able to see it. So here's up top, and I'll move down in a second. Again, check answers. We'll just go through specifics today and or tomorrow. What are you doing with your change in y in 25? What is y? Or what is the output of the function?
Yeah, a circle.
This is area. So your change in y is area. What's your change in x? What's your input?
Different radius.
So what is the rate? What rate are you looking at if you take change in y over change in x?
The change of the area of the circle over the change in the radius.
Yeah, what it is, it's a number. It's an interesting unit. It's not like feet per second or anything, but it's still a rate. What it shows you is the relationship between changing the area of a circle, meaning you're making it bigger or smaller, when you change the radius. Meaning if you move the radius a little bigger, how that affects the area. It's the rate that the area is changing as you change the radius. And that's going to have units of inches squared per inch. Does that make sense? Interesting problem. We're going to be dealing a lot with that as the year goes on. So I thought that was an interesting one. Are you guys ready? Alright, this should be the last. 29. Entire section. Even on those little charts with those little P and Q points. Again, you may not have exact values, but you just guesstimate where that point is and you plot the points and then you just take change in y over change in x. If you want the secant line or average rate of change. If you want the instantaneous rate of change. You take change in y over change in x only for some value, and then like 3, and then some value really close. 3 plus h. Does that make sense? So let me ask you some questions. Let's do some problems. I have x squared plus 2x plus 1. I want to know the average rate of change on the interval 1 to 3. Answer that question for me. I have some function, and I want to know the average rate of change on the interval 1 to 3. Talking about it in your groups. How are you doing this problem? What are you doing? Check the person next to you. What are they working on? Talk your way through it so they're staying with you. Are they sitting there waiting for the answer? Are they trying to do something? What are they doing? Be accountable to the group. I want to know, my question to you is, what is the average rate of change for this function on this interval? Yeah, just state your 2 points. Whenever you do anything with an average or instantaneous, always, always, always state your 2 points. What are your 2 points in this case?
1, 4,
1 comma 4 and
3, 16.
3 comma 16. You have your 2 points, so how do you find the average rate of change between them? What do you do?
By 1 y2 minus 1.
Yeah. y2 minus y1 over x2 minus x1. Change in y over change in x is equal to 12 over 2, which equals 6. What does that number stand for? So I had a couple of other things. Let's start with the word slope. The slope of what? No. What's the difference between a tangent line and a secant line? Yeah, the secant line is the line that connects the 2 endpoints. This number, what we just calculated, was the slope of that line, of the secant line. The tangent line is that instantaneous rate of change. So let's do that now. Why don't we check the point 2? I want to know what the instantaneous rate of change is for this function at 2. How do you do that? Talk about it in your groups. Check the person next to you. Tell them they can fill that out later. That's all good. We got all day to do that one. But this one, this problem, right here, right now. Is that Jesus Jones? Who sings that, Mr. Jeff? Right here, right now? Yeah. Yeah, right. What are you doing? Are you waiting? Are you guys going to wait for someone to do it on the board? Are you going to sit there and wait? Yes. I want to know the instantaneous rate of change at x equals 2. Instantaneous rate of change.
Jesus Jones.
What do you do? Are you talking? Or are you just going to make a little picture until we start talking about it? What are you doing right now? Test is Friday. Maybe we'll have a quiz on this tomorrow. It seems like we're enjoying it.